working on called the Orion 10 project. And it uses a medication called Inclisiran. Who here is familiar with that, just so I get a little bit of a sense? So most people have not. So let me explain it to you. So Inclisiran is one of the new products that works by blocking the effects of PCSK9, which, as I think you probably know, is a bad protein that leads to higher levels of cholesterol. And we were instrumental in getting 2 products to market that block the effects of that protein. Do you remember what those drugs are? Repatha, and what was the other one? Praluent. You guys are good. So Repatha and Praluent are both on the market, in part because of our involvement in this and, of course, other centers around the world. But those drugs work by taking a fully human monoclonal antibody and giving it every 2 to 4 weeks, and then preventing the PCSK9 molecule from interacting with the liver receptors by having the antibody bind the bad protein. And it works great. We can bring down PCSK9 levels tremendously. We can drop LDL cholesterol tremendously. But the one problem is that your liver is continuously making PCSK9. So you have to continuously give the monoclonal antibody. And as you know, monoclonal antibodies are very expensive to manufacture. So people are saying, well, are there other approaches that we can use? So people thought about, well, can't we use like small molecules, like little pills that we use for most patients? And there's some distinct challenges of getting a small pill into the system that'll block the effects of PCSK9, although people are still working it. But somebody had a really, really clever idea. And this is based on our improved understanding of genetics. So one of the things that people have researched that have nothing to do with cholesterol, by the way, is how our bodies fight viruses. So just remind everybody, a virus is basically a piece of nuclear material that gets into our system and then tries to take over the mechanism of cells to reproduce itself in all its nasty byproducts. That's what viruses do. They basically take over the cellular mechanisms. And viruses don't really have any existence outside of other cells, human or other animal cells. So they have to, by definition, take over these cells. Well, why don't viruses take over our bodies all the time? Well, the reason is because we have natural defenses against viruses. And it turns out that one of the defenses that was discovered is called RNA interference. And basically what that is that when the body recognizes a foreign piece of RNA, it can then teach the cells not to produce that protein. And there are parts of our body that will recognize these malevolent type of proteins and prevent the nuclear code from being translated. So people said, wow, well, if the body has that intrinsic mechanism and it can do that to prevent viruses from reproducing, could it do that for other proteins? And the answer is yes. So people figured out what the sequence of coding is for PCSK9. And the neat thing about PCSK9, it's really only made in the liver. So all you need to do is prevent its production from the liver. And so people are very clever, and they took the piece of code for PCSK9 and they put sugar molecules on either side of it, and then created sugar molecules that are specific to receptors in the liver. So the receptors are finding these sugar molecules, they're pulling the whole molecule, including the code for the PCSK9, into the cells, and then they migrate to different parts of the liver, including the hepatocytes, where PCSK9 is made. And eventually, this piece of protein is recognized by the RNA interference parts of the cell, and they come into their proper place, and they block the production of this protein. So we were involved in studies with Inclisiran, which is the generic name for this particular product that can block the production of PCSK9 in the liver. And we found that if you give a high enough dose, you can pretty much shut down production of PCSK9 by the liver for months, maybe even 6 months. How cool is that? Is that we can give one injection and all of a sudden we don't make this bad protein for 6 months. And the beauty is that we don't have this continuing problem of having to inject every 2 or 4 weeks to sop up the protein that's being produced by the liver constantly. We basically shut it down. On the other hand, there is a shelf life. So for whatever reason we need to stop giving this product, we know that after a certain period of time, the effects of that product will go away. So the other thing that's really cool is that it's intrinsically less costly to manufacture inclisiran compared to monoclonal antibodies. Remember, monoclonal antibodies in the modern era are fully human, and they are developed basically by putting human genes into mice, and then to have mice produce these things in combination with what's called the hybridoma, and that's basically a multiple myeloma cell. So it's a very complex technology that results in the generation of these monoclonal antibodies, and then there's all these purification processes, et cetera, et cetera. So even with the best of efforts, and even when you get up to scale, monoclonal antibodies are always expensive to manufacture. Inclisiran is a little piece of code. It's a much, much smaller molecule. All you need to do is put the pieces of that together, put some sugar molecules on the outside, and presto, you have a drug. And so intrinsically, it's much less expensive. So one of the theories is that if this works as well as the monoclonal antibodies, we should reduce the price of giving anti-PCSK9 therapy. So hopefully that makes sense and why I'm so particularly excited about this particular product. And we have the opportunity now to get folks into these studies using this product at 3 sites in our network. And so it's a really cool opportunity for us to really be on the cutting edge of a new way to treat cholesterol problems and a new way of approaching the whole PCSK9 dilemma.